Welcome to today's explainer. You know, Indiana Jones might absolutely hate snakes, but grid engineers, they're practically falling in love with them. Just picture this for a second. You look up at a massive high-voltage power line, and you see what looks like a metallic, mechanical snake just effortlessly sliding along the energized cables. No way, right? It sounds like something pulled straight out of a sci-fi movie. But I promise you, this isn't fiction. Today, we're diving into the mind-blowing futuristic tech that's literally maintaining and protecting China's huge electricity grid right now. We're going to look up close at these autonomous machines, figure out exactly how they tick, and see why they represent a massive leap forward for global infrastructure maintenance. Let's get into it.
So, we kind of have to start with this basic but super striking question. Why on earth are robotic snakes crawling along China's high-voltage power lines? Well, out in the rolling hills and the urban outskirts of Kunming, that's the capital of Yunnan province in southwestern China, these sleek, segmented robots have actually become a pretty common sight. And they aren't just there by accident, and they definitely aren't some quirky novelty. These things are actively crawling along live, fully energized wires to sniff out faults in real time. It is a visually stunning fix to a seriously high-stakes problem.
Okay, let's dive into this. On the agenda today, we've got the mechanical guardians, high stakes and hazards, how the snakes work, real-world results, limitations and next steps, and finally, the future of infrastructure.
Section 1. The Mechanical Guardians.
This tech represents a monumental shift away from how utilities have managed grid maintenance for decades. These autonomous machines are being deliberately deployed by the China Southern Power Grid and its local branch, the Guangzhou District Power Supply Bureau. So instead of sending out traditional human crews to physically go up and check the lines, authorities in Kunming are using these robotic systems to continuously operate directly on the live wires. Think about that. They're out there actively inspecting, monitoring, and protecting the grid, and they don't even need to shut the power off first. It's a real game changer.
Section 2. High stakes and hazards.
To put the sheer pressure of all this into perspective, consider this number, 12.9 million. That's roughly the number of students in China who sit for the Gaokao, the massive national college entrance exams. And these exams pretty much determine a student's entire future. Now imagine your whole life depending on the AC and computer staying on during a massive heat wave. Even a momentary outage would be an absolute catastrophe. During this incredibly high-stakes period, exam venues demand absolute, uninterrupted electricity for lighting, security, and climate control. Add rapid urbanization and renewable energy into the mix, and reliable electricity becomes entirely non-negotiable.
Now, the old ways of doing this, they face some major severe limitations. Having human crews work at dizzying heights on live equipment is obviously a massive safety risk. You might think, well, what about drones? Sure, but aerial drones face strict flight restrictions anywhere near airports. They suffer from crazy electromagnetic interference from the power lines themselves, and they're pretty much useless in bad weather. Helicopters? Incredibly expensive and just not great for detailed close-up inspections. By contrast, these robotic snakes move right on the lines. They bypass drone no-fly zones, they shrug off bad weather, they keep human workers safely on the ground, and they provide this continuous, barrier-free, close-up monitoring. It's absolutely brilliant.
Section 3. How the snakes work.
So let's talk about the actual engineering here. The core of this technology is a concept called biomimetics. Basically, that's design that mimics natural biological systems. The robot has this flexible, multi-jointed body specifically built to move exactly like a real snake. This biomimetic design lets it wrap securely around the cables, spiral its way forward, and gracefully dodge tricky obstacles like insulators or connection points. And just like a real snake, it relies on its head to perceive the world around it. That head section is packed with high-resolution cameras and thermal imaging devices.
What do those sensors actually do? Well, they allow for real-time fault detection. They're actively scanning for broken or frayed wires, corrosion, and everyday mechanical wear and tear. The thermal cameras are especially cool because they can instantly spot abnormal heat signatures, stuff that usually points to an overloaded component or a loose connection. The second it spots a potential issue, it pings the maintenance crews, who can get out there and fix it before the power actually goes out. That shifts grid maintenance from just reacting to broken things to being truly proactive.
Now, what's really interesting about this slide is the power system. You're probably wondering, right? How often do they have to come down to charge up their batteries? The genius answer is, they don't. These robots use something called non-contact inductive power harvesting. As they slither along, they literally suck up energy directly from the strong electromagnetic field generated by the live current flowing right through the cable they're crawling on. It's like magic, but it's just physics. Because of this,
They can potentially operate 24 hours a day, 7 days a week, totally autonomously, without ever heading back to a charging base.
Section 4. Real-world results.
And look, this isn't just some shiny prototype sitting on a lab bench somewhere. According to local power authorities, these robotic snakes have already successfully inspected over 130 kilometers of actively deployed power distribution lines in the Kunming area. That even includes hypersensitive routes like the ones near airport no-fly zones and those critical exam centers during the Gaokao testing period we talked about earlier.
When you look at the performance data, it's pretty striking. These robotic snakes are hitting roughly 3 times the efficiency of traditional manual methods when it comes to speed and coverage. Just one robot can clear massive distances entirely on its own, completely unfazed by human endurance limits or, needing daylight to see. This threefold boost in efficiency translates directly into finding problems way faster and drastically cutting down on grid downtime.
And this brilliantly illustrates a much larger strategy at play here. The snakes aren't out there working all by their lonesome. They are part of a massive layered surveillance ecosystem. Chinese power utilities are putting robot dogs on the ground for substation checks and hazardous spots. They've got drones covering the open airspace where they're allowed, plus fixed monitoring cameras. The whole shebang coordinates together to manage these crazy high-voltage environments, which keeps the human workers entirely out of harm's way.
Section 5. Limitations and Next Steps.
Of course, we do have to ground ourselves and acknowledge a few realities. First off, right now they are mostly limited to distribution lines. They aren't quite ready for the absolute highest voltage transmission lines that cross huge geographical spans. Secondly, extreme weather, we're talking heavy ice or severe storms, can still seriously mess with their performance. And on the economic side, the initial investment is super steep. Designing and building highly specialized biomimetic robots is not cheap. Plus, despite that awesome wireless power harvesting, they do occasionally need to be physically retrieved for hardware maintenance or software updates. But engineers are actively iterating on the designs to tackle these very hurdles as we speak.
Section 6. The future of infrastructure.
Looking down the road, we can absolutely expect deep integration with artificial intelligence. So instead of just detecting a fault that's already there, AI will crunch the sensor data to forecast failures before they even happen. We are also going to see these robots scaled up for those high-voltage transmission lines. And this is vital because this isn't just a China story. As power grids age everywhere, literally, probably right in your own city, and as we face growing shortages of skilled labor globally, this kind of autonomous ecosystem is basically the inevitable blueprint for keeping your lights on in the future.
It's an incredible evolution in maintenance tech that delivers tangible benefits way beyond just the power lines. It really leaves us with a provocative question to chew on. As AI and robotics merge seamlessly into these layered autonomous ecosystems, are we actually witnessing the end of the human infrastructure inspector? The rapidly shifting landscape of our energy infrastructure certainly suggests that the quiet, persistent work of these mechanical guardians is really just the beginning.
Thank you so much for joining me for this explainer. I hope you found it as fascinating as I did. For more on these incredible innovations, be sure to visit our website, Fair Solution. Catch you next time.